Okay guys, I'm back from my trip to Westech. Got to run the 292 with the Dominator. If you haven't seen that, check it out. That video is right here. Also got to run it with a turbo. If you haven't seen that video, check it out. It's right here. I also got to do some prep on the Buick and hopefully get it ready to test. Got to disassemble a Cadillac, which is awesome. And if you haven't seen that video, it's right here. I know there's a lot of videos, but it was a cool trip to Westech. Now I'm waiting for more dyno time to become available. I've got a bunch of intakes being sent to me for the 292. Gonna run an intake test. Got cams coming up for that thing. Gonna run more boost with a 4-barrel, all kinds of cool stuff. Then I'm gonna head out and visit Courtney out there. He's gonna show me some 500 Cadillac stuff. We got a lot of cool stuff coming up. But I'm back home. I'm gonna take a look at one of the older tests that I did on a 3800 Series 2, you know, Pontiac Grand Prix GTP Buick GS motor. We did a lot of cool testing with it, but as you will see, everything didn't go perfect. And this test will show you why I want to redo and revisit this test, run all the stock stuff, run all the mods, but more importantly, I want to do a big bang on this motor. This thing needs a turbo. Yes, it's great that it has a supercharger and all that's fantastic. We can turn the boost up and we can add ported heads and cams and all that stuff's really cool. What it really needs is a turbo and like a mega boost, and let's see how far it can go. Let's check out the results. To get this party started, we put the 3800 Series 2 motor up on the dyno. It came from a 98 Grand Prix GTP, and we ran it all stock. And by that I mean it wasn't really all stock because we had a Tech 2 engine management system that we ran out that was kind of problematic for this testing. But it did have the factory throttle body mass air meter, which we didn't use because we were running at speed density. It had the factory 3.8 liter blower pulley. It had the factory exhaust. All we did was connect from the outlet of the factory exhaust. We just put a bend on it so we could run it on the dyno. And we ran it stock, and then we ran it with pulleys and, you know, a variety of different normal modifications. Now, guys have done a ton more stuff now. This was way back in the day, but I got some interesting results, and I wanted to ask you guys about it, especially the guys that have been running a lot of 3800 Series 2 stuff since then, to figure out, you know, help us kind of figure out what's going on. And more importantly than that, just to figure out, and I know that the answer is yes, if we should do a big bang on one of these, because I'm really excited about it. I think this thing has a ton of potential and should make really big power. But equipped like in stock trim with the factory pulley, this thing made 293 horsepower, 304 foot-pounds of torque, and I know there's got to be some guys out there that are always thinking, hey, this thing was rated at 240 horsepower, why does this make so much more? Same as always, we run it cold, it has an optimized tune, it has an open throttle body, no air intake, it obviously has no exhaust, so all of this stuff's combined to have it make more power. So the first thing we did, obviously, was to increase the boost like everybody. So we did a dial your boost pulley system and put the hub on so that we could do interchangeable pulleys to make it really fast. We put a 3.4 pulley on there, and peak power jumped up to 306 horsepower, 328 foot-pounds of torque. We didn't get a consistent gain, and I think if we look at the airfield, we'll see that the tune on this was kind of the issue. This had a richer mixture on the 3.4 compared to the stock pulley, which is why we didn't kind of see a straight track. And we saw a similar thing. We also went up down in pulley size and up in boost. Put a 3-inch pulley on her, big gains in torque, all the way up to 355 foot-pounds, but power fell off, and it was a little bit richer. But I think something else was going on there too. Now, I didn't do the tuning on it, so I can't tell you exactly what the timing was on all these. The Tech 2 was not very user-friendly when we were trying to do this. But this is the kind of a typical result thing. If we increase the boost, it usually picks up power everywhere, and I'm sure that we would do that if if I was doing this test today, which we want to do. But these are the results basically from the pulley change. So now let's take a look at some other changes that we made, you know, other modifications on our 3800 Series 2. After running our testing with the various different size pulleys, we actually reinstalled the 3.4-inch pulley, and because that seemed to be working the best. And then we did an upgrade on the throttle body mass air meter. Now it's a combination on the 3800 Series 2 stuff. The mass air meter is kind of housed inside the throttle body, and what we do is port the entry and make sure that the mass air meter flows a little bit more, and usually we pick up quite a bit of power from that. Here was our stage 2 mass air meter upgrade. So we picked up 5 or 6 horsepower with that from the additional flow, and we'll show that when I show you the boost curves that it does indeed pick the boost up. Excuse me, does indeed pick the boost up just a little bit. So our next test was to install a set of ported heads, which this was an interesting thing. I had a friend of mine port a set of the heads, and you can take a look at here and see all the stuff that they did. I mean, they look nice. I didn't flow test them. Maybe I should have, especially after seeing these results. But here's what happened when we installed the set of ported heads. We replaced the factory heads that came on the motor with these ported versions. And we saw basically like no change in power. We saw, and when we look at the boost curve, we also saw no change in boost. So let me know out there, guys. I know that when we run ported heads on almost anything else, we pick up power and, you know, we drop boost and pick up power, which is what we normally see. And we didn't see this on this application. I'm thinking it probably was just they maybe didn't do a great job on porting the heads. Maybe they made them look like they were ported without actually improving the flow. So let me know out there, guys, what kind of results have you guys had with ported heads? And the other thing is we put ported heads on a combination that had a fixed pulley ratio, obviously, but it also had a stock cam in it too. So, you know, there maybe the gains are not quite as great on that kind of application. So the next upgrade we made was to install an intercooler, and this is an air-to-water intercooler, and we ran Dyno water through it, and you can take a look at the photos here. You know, it has the long studs, and so we could sandwich the intercooler between the blower and the factory intake manifold. But here's what happened when we put the intercooler on. I mean, we picked up a little bit of power, and I'm going to go ahead and what I'm going to do here is I'm going to zoom in so you guys can see this, so we can expand that a little bit. But you can see the red line here. I mean, but we're only talking about a difference of, you know, 4 or 5 horsepower. Again, we saw a slight drop in boost when we put the intercooler on, which is what we would expect, both from a change in charge temperature, which I don't have the charge temperature data, unfortunately, but there's always a change in charge temperature, especially, you know, with a roots blower, which is going to be fairly hot at all the boost levels. So we saw a change in, I'm sure that there was a change in charge temperature, but we definitely saw a change in boost, which drops down. So part of that is from being colder, but the other part of it is obviously from a restriction from the intercooler itself. So now let's take a look at the final test, which actually did show a pretty big power change. So our final test was actually to replace the Eaton supercharger. So I made an adapter plate to allow us to run a KENNE twin screw blower. Now we know that the twin screw design is more efficient than a typical roots blower. So, and the twin screws obviously had a great deal more capacity. I think this was a 2.1 liter KENNE, so it had much more capacity than that M90 does. So if we take a look, we'll remember, here's what happened. This is the stock one. This is what happened when we put our 3.4 pulley on there. And here's what happened when we put our 3-inch pulley on there. Although I don't think the top end is indicative. I think we would just have railroad tracks, like I said. But here's what happened when we installed the KENNE supercharger. And remember, I'll go ahead and show you the boost curves and all this stuff too. So when we put the KENNE on there, obviously we had a lot more capacity, and the thing made a lot more, well, a lot, I say a lot, a reasonable amount more power, 367 horsepower. And that should have continued. I think, again, we were running into a tune problem or a belt slippage problem or something else that was stopping this thing from continuing to go up, because the power curve should continue to rise, since we definitely had a rising boost curve with the KENNE. But it does go to show you that a greater displacement blower, obviously the bigger when it comes to positive displacement blowers, bigger is definitely better. Now we did not run the KENNE with the intercooler because I couldn't use the adapter and the intercooler together. So the KENNE was run with no intercooler. But having a sandwiched intercooler obviously is always a good idea. Cooler charge temperature, especially says on this KENNE, I think we were up near 13 pounds of boost. It was supplying a lot of boost. What this combination really needed, I thought it needed ported heads, but obviously not the ones that we ran. But it really needed, I think a camshaft would have helped this thing out a lot. But then after that, and after we, run to the limit of these superchargers, like I'd like to put a supercharger from the Gen 3 motor on here and kind of run that thing up, and with a big throttle body and stuff, that would be kind of cool. But then after that, obviously, this thing just needs turbos. So what do you guys think? Let me know in the comments. Turbos, big bang, 3.8 liter. Yeah, of course. Whenever we run any kind of force induction combination, I always like to obviously log the boost pressure, because the boost pressure will tell you like what's going on. If it's not working the way that it should, look at the boost pressure. If it is working the way that it should, look at the boost pressure, and it'll kind of tell you if you have a pulley slipping or something. You know, kind of give you a really good idea. It's always better to have more data than not. So a lot of guys think with a positive displacement blower that you have, as soon as you stick your foot in the throttle, you have immediate boost that goes all the way up and it's nice and steady going across. The reality is that's not the case. The airflow needs of the motor obviously change with RPM and when the motor is efficient and when it's not. And then the airflow supply, a positive displacement blower provides a fixed amount of air for each revolution. And as you go every revolution, you know, the revolution per RPM, that determines how much airflow it's supplying. And if we change the pulley, we increase the amount of airflow that's supplied relative to the engine speed. So here is the boost curve supplied on a bone stock one. Obviously we had an open exhaust and an open throttle body, but you'll note that below 3,000 RPM we had 3.9 pounds of boost, and we had 7 pounds, which is what everybody says that these things make, but it only did that like out at 6,000 RPM. So it'd have been nice to have 7 pounds down at 3,000 RPM, then you have a lot more torque. But let's take a look and see what happened when we installed a 3.4 pulley in place of the stock 3.8. And kind of as you would expect, it basically just made more boost everywhere. The 3.4 pulley is the red line. And the same thing happens when we install an even smaller 3-inch pulley. Again, more boost everywhere. So pulleys change the blower speed, more airflow. The airflow needs of the motor are the same, so we see an increase in pressure, and that increase in pressure will usually increase power. But now here's the interesting thing. Let's take a look and see. I'm going to get rid of the 3-inch pulley because that's not going to be relevant. We ran the bigger throttle body with a 3.4-inch pulley, so that's the red line. So as we can see, now the throttle body is the red line, and the 3.4-inch pulley is the green line. Our throttle body did indeed improve boost and improved airflow basically into the blower and therefore boost out of the blower, which is what we would expect from an airflow improvement before the supercharger. So that should improve power. Now let's take a look and see what happened when we put the ported heads on. I'm going to go ahead first and get rid of our throttle body. The ported heads really had kind of very little change compared to just the pulley, and actually honestly compared to the pulley and the throttle body. I mean, the ported heads, I would expect a much bigger change. The airflow or the boost should have dropped with the ported heads, and they just didn't do that. So now let's take a look and see what happened when we installed the intercooler. So the intercooler is in red. And the intercooler did indeed, the boost dropped with the intercooler. Again, for two reasons. One, the air is colder because you're cooling the boosted air. The charged air is going to be hotter under boost. You're going to cool it back off with the intercooler. So you'll see a drop in pressure. And you'll also see a drop in pressure because we were measuring this in the intake manifold down under the intercooler and the supercharger. So the intercooler itself is obviously going to be some kind of restriction. So you'll also get a boost drop there. So when we added the intercooler, we were dropping from 6.8 at that point, 6.8 down to 6.1, so 6 or 7 tenths, you know, of a pound of boost. Now let's take a look and see our final thing. This is when we installed the KENNE bell. Basically, more boost everywhere, more power everywhere. I mean, that kind of goes hand in hand. And you can see the boost is rising both on the factory M90 and with the KENNE bell. We have kind of a nice gradual increase, and then out past 5,500, it really starts to ramp up. This thing really needs a camshaft. If we had a camshaft, we wouldn't see that same kind of rise. We need to make the motor more efficient so we can bring the boost down and the power up. Okay guys, you can see this test didn't run perfect. I mean, I don't like ever running tests and not having the air fuel be exactly the same and the timing be exactly the same. And when we're running tests on boost, I wanted to do what it's supposed to do. There should be nice railroad tracks every time we go up and boost, but that didn't happen. That's why I want to revisit this test. I want to redo it and show, not that we don't already know what's going to happen. The boost is going to increase, blah, blah, blah. But I do want to find a good set of ported heads. I want to put a good cam in it. We want to put ARP head studs on it. You know, do some ring gap on it. Make sure that this thing is prepped. Then I want to add a turbo. Now, let me know, what should I do? Should I put the factory like NA 3.8 liter intake on there? Should I try to make a housing for the supercharger intake? Let me know what you think I should do. I'm definitely gonna run a big air to water, like an external air to water intercooler. We'll run a turbo on it that can support 600, 700, 800 horsepower, how much ever power you guys think that this thing will make. I think it will make a lot if I can get the NA power up to, I don't know, I'm thinking somewhere between 250 and 300 with the right camshaft and ported head and the right kind of intake. Then we start multiplying that with a turbo, good things happen. Thanks for watching, guys. Make sure, again, like, share, subscribe, do all that stuff. I'll keep testing.